Hey everyone, welcome to Homeschooling SAT Prep channel. Today we are going to start a new chapter. The name of the chapter is Scatterplot. In this chapter, we are going to have two videos. In part 1, we will take Scatterplot with linear relationship, and in part 2, we will take Scatterplot with non-linear relationship. In part 1 video, we will start with the basics of Scatterplot and linear function. After that, we will take 11 previous year problems of low, medium, and high difficulty level. And at the end, I'll give you 5 practice questions which you can solve by yourself and write down the answer in the comment section below. Till 2023, we used to get questions in Scatterplot related to linear relationship. But recently, College Board has added these two questions. And because of that, we have to cover the Scatterplot with non-linear relationship. If you want to seriously prepare for SAT examination, you can check out our various courses on homeschooling app and website starting at a very affordable price. All the links are provided in the description below. Now, this is our syllabus here. We have already covered these shaded topics. Today, we are going to cover two variable data, models, and scatterplot. Now, let's move on to the basics of scatterplot. Before I start the basics of scatterplot and linear equation, I want to tell you something about this video. This video is going to be very, very long. It's going to be around 1 hour, 25 minutes. So if you know the basics of scatterplot and linear equation, you can directly jump to this particular timestamp. But I'll still suggest you to go through the basics first, then go to the questions. Now, what is a scatterplot? Scatterplot is a graph that is used to represent two sets of data or variables. Now, as we can see here, this is our x-axis on which we have process input of a computer, and on y-axis, we have quality characteristics of a computer. And these dots are called as data points. So let's take this data point here and let's find out what this data point is saying. So we will correlate it with x-axis and y-axis. So what this data point is saying that when the process input of a computer is 9, then that computer has the quality characteristics of 96. So this is how scatterplots are plotted by using data points. Now we have various types of correlation in a scatterplot. It can be a positive correlation, negative, or a no correlation. So what is a positive correlation in a scatterplot? As we can see here, the data points are put on the graph and are rising when we move from left to right. This means that when the value of x is increasing, the value of y is also increasing. So a positive correlationship is when the data points in the graph are rising, moving from left to right, then the scatter plot shows a positive correlationship. It means the value of one variable is increasing with respect to another. As we can see, x value comes here, then y value is coming here. Similarly, when x value is increasing, the y value is also increasing. Now, in positive correlation scatter plot, we have three types of positive correlationship. It can be a perfect positive correlation, high positive correlation, or a low positive correlation. When the graph is rising or the data points in the graph are rising in almost a single straight line, then it is called as a perfect positive correlationship. Now in this graph, as we can see, the graph is rising, but the data points are slightly scattered or concentrated or they are nearby to each other. So we call it as a high positive correlation. But when the data points are rising and are scattered and the concentration is low, then we call that as a low positive correlation. Now, in negative correlationship, it is inverse of positive correlationship. In positive, the graph was rising when we move from left to right, but in negative, graph will fall while moving from left to right, which means when the value of one variable is increasing, the value of other variable is decreasing. As we can see here, the value of x is increasing, but the value of y is decreasing. So these types of correlation in a scatter plot is called as a negative correlation. And in negative correlation, we have three types of correlation: perfect, high, and low. So when the data points in a scatter plot is falling almost in a straight line, then it is called as a perfect negative correlationship. When the data points are falling, but they are close to each other and having a high concentration while falling, then we call it as a high negative correlation. And, when the graph on a scatter plot is falling, or the data points on the scatter plot is falling, when we move from left to right, and the data points are scattered away from each other or having a low concentration, then we call that low negative correlation scatter plot. Now we have a third type of scatter plot, no correlation. As we can see here, all the data points are scattered all over. When we have a scatter plot where we cannot say that the data points are increasing or decreasing, then we call that scatter plot as a no correlation scatter plot. Now, there's one more concept in scatter plot, that is the line of best fit. So the relationship between the two sets of data can be approximated by a line. It represents the relationship between two sets of data graphed in a scatter plot. So as we can see, these are our data points, and we can see it is a positive scatter plot. And what is the line of best fit? Line of best fit shows the trend of the data. As we can see here, the data points are rising, so it is showing a trend of the data points. So how can we draw a line of best fit? So it need to satisfy two criteria. The first one is it should approximate the slope or trend of data set. As we can see here, all the data points are rising, so our line of best fit will rise here. And this one more criteria, it should roughly split the data points into half. So as we can see here, this is our line of best fit. Now we have 1, 2, 3, 4, 5, 6, 7, 8 data points above the line of best fit, and 1, 2, 3, 4, 5, 6, 7, 8, and 8 data points below the line of best fit. So we can say that the line of best fit is splitting the data points into half, because we are having equal number of data points above the line of best fit and equal number of data points below the line of best fit. Now let me give you one more example. If I make a line of best fit like this, does this line satisfy the criteria of line of best fit? So let's check one by one. So it should roughly split the data set into half. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 on the right side of the line of best fit, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have 9 data points on the left side of the line of best fit. So it is satisfying condition number 2. But in condition number 1, it was given it should approximate the slope or trend of the data set. So as we can see, trend is increasing, but here we made a line of best fit with decreasing trend. So this is incorrect. Now let me take one more example here. What about a line of best fit like this? In this example, we can see that it is below all the data points. So let's check both the criteria one by one. It should approximate the slope or trend of the data set. Yes, it is following the first criteria because it is along the slope. Let's check out the second criteria. It should split the data into half. No, it is not splitting the data into half. So this is not a line of best fit. So a line of best fit is a line which approximate the slope and split the data points into half. Before we move on to the questions, you should have a basic understanding of linear equation. So what is a linear equation? So a linear equation is an equation in which the graph is a straight line, and it is written in the basic form as y is equal to mx plus b. So if the equation is given in this form, y is equal to mx plus b, then it is a linear equation. Now, the graph of a linear equation is always in a straight line. So it can be an increasing graph, or it can be also a decreasing graph. And it's written in the form y is equal to mx plus b. Now, b is called as y-intercept. So what is y-intercept? Value of y at x is equal to 0. So let's put this is our basic equation here. So let's put x value 0 here. So y is equal to m, and instead of this x, we'll put 0 here plus b. So m into 0, this thing will be 0. So y is equal to b. So we can also say that b is also equal to y. So what is y-intercept? Y-intercept is value of y at x is equal to 0. So here we have put x is equal to 0. After putting x is equal to 0, we can see b's value is equal to y. That's why we call b as a y-intercept, because b's value is equal to y. Now here m is called as your slope. Now slope can be of two types. It can be when the value of m, slope m, is positive, it is called as a positive slope. When the value of m is negative, we call it as a negative slope. When we have the value of m as positive, then we have a graph like this. That would be a rising graph. When the slope is negative, we have a graph like this. That is a falling graph. We also have a formula for slope, where slope m is equal to rise by run. We can also write it as a delta y by delta x. That is change in y-axis divided by change in x-axis between two coordinates. You will further understand the concept of slope when we will take questions here. Now, what is x here? X is an independent variable and y is a dependent variable. Why is called as a dependent variable? Because whenever we put various values of x, like here we are putting x as -1, 0, 1, 2, then the value of y will change, and the value of y will change as per the value of x. So we can say that y value is dependent on the value of x. That's why y is a dependent variable. Now let's take an example here. We have a linear equation y is equal to 3x plus 2. I want you to find what is the y-intercept, that is b. Then what is your slope, that is m, and what is the type of slope. I want you to pause the video here and try this question here. I hope you have tried this question. Now let's solve this question together. So we have the basic equation y is equal to mx plus b. So as we can see, b is our y-intercept. Correspondingly, so in corresponding to b, we have 2 here, and corresponding to m, we have 3 here. So our y-intercept value would be 2. Our slope would be 3. And the value of m is positive, so we have a positive slope. And our graph would be a rising graph. We can also check that b is the y-intercept is 2 or not. So as we already know, the value of y at x is equal to 0. So if we put x is equal to 0 in this equation, so y is equal to 3. Instead of x here, we will put 0 here. So we can know 3 into 0 is 0. So y is equal to 2. So your y-intercept would be 2. Our slope is m here, that is 3. And the value of slope m is positive 3. So that's why it will have a positive slope. In your exam, you will get two types of question. Either a linear equation would be given to you, and you have to find the slope or the corresponding graph of that linear equation, or a graph would be already given to you, and you have to find what is the linear equation. So now let's solve when a linear equation is given and we have to find its graph. So we have a linear equation y is equal to 3x plus 2. Now what we're going to do here is we're going to put various value for x, and we have to find what is the corresponding value of y. So when x is equal to -1, y is equal to 3 into -1 plus 2. So that is going to be -3 plus 2. That is -1. So our y value is -1. When we take x is equal to 0, so y is equal to 3 into 0 plus 2. So 3 into 0 is 0. So that is equal to 2. So this is your y-intercept. Now let's take x value as 1. So when x value is 1, y is equal to 3 into 1 plus 2. That is equal to 5. So your y value would be 5. Similarly, if we take x value as 2 and we put it in the linear equation, 3 into 2 plus 2, so 3 into 2, 6 plus 2, that is 8. So when x is equal to 2, y is equal to 8. Now, as we have read that y is called a dependent variable because y value is changing as we change the x value here. Now, what we're going to do here is we are going to plot these coordinates of x and y from this linear equation on the graph. So when x is equal to -1, y is also equal to -1. So this is our plot here, -1 and -1. Here our x value is -1 and our y value is also -1. So we'll have a coordinate here. I will have a data point or a coordinate here. Now, when x is equal to 0, y is equal to 2. So x is 0 here and y is 2 here. So we'll get a coordinate here. So 0, 2. Now, when x is equal to 1, y is equal to 5. So 1, x is equal to 1 and y is equal to 5. So we have 1 and 5. Now, when x is equal to 2, y is equal to 8. So x is equal to 2 and y is equal to 8. So 2, 8. Now, what we're going to do after plotting these points, we'll draw a line like this. So as we can see, the graph is a rising graph. So it has a positive slope. Now, sometime you will be given this graph here and you have to find the equation. Let's say if the graph is given with these coordinates and you have to find what is your linear equation. So as we know, y is equal to mx plus b. So what is b here? B is the value of y when x is equal to 0. As we can see here, when x is equal to 0, our y value is 2. So b is going to be 2. Now we have to find what is m. So as we know, m is our slope. To find slope, we will take any two coordinates here. So let's take these two coordinates. So this is coming before, because when we are putting the data, we are putting an increasing number. So this one come before, so x1, and this one is your y1, and this is your, and we are taking another point, this one. We're taking these two coordinates. So this is your x2 and y2. So these two are coordinates. So as we have read in the basics, that slope formula is rise by run or delta y by delta x. That is equal to y2 minus y1 divided by x2 minus x1. So as we know here, y2 is 5, so 5 and y1 is 2 divided by x2. So x2 is 1 and x1 is 0. So 5 minus 2, that would be 3, and divided by 1, so 3. So our slope m is 3. So we can write this equation, y is equal to mx. So m is our slope, and we have already found out that it is 3. So 3x plus b is our y-intercept. So y-intercept is the value of b at x is equal to 0. So here, when x is equal to 0, y value is 2. So 2. So from the graph, we can also find the equation like this. Before we move to the next example, I want to teach you one more concept about slope. As we know, slope m was change in y-axis, that is y2 minus y1 divided by x2 minus x1. And when we found it out, it came 5 minus 2 divided by 1 minus 0. So 3 by 1. So what does this slope 3 means? Slope m3 means that every time x increases by 1 unit, y increases by 3 unit. Now we have taken these two coordinates. So as we can see here, x is increasing from 0 to 1. So this is our delta x, and y is increasing from 2 to 5. So this is our delta y, that is 3. And this is our delta x because it is increasing from 0 to 1. So delta x is 1. So we can say that the rate of change is 3. So what is rate? So sometime you will get a question, find the rate of change of the graph. So we have to find the slope of the graph. So as we can see here, for these two coordinates, for every time we increase 1 unit on x-axis, or the delta x is 1, then the change in y is 3 units. That is delta y is 3. That is called as slope. Now instead of these two coordinates, if we have taken uh, this one and this one, still we will get the same slope. So if we take this one and this one, so slope m is equal to y2 minus y1. So this is going to be our y2. So that is 8, and our y1 is 2 divided by x2 minus x. So x1 is 2, x2 is 2, and x1 is 0. So 2 minus 0. So that is going to be 6 divided by 2. So it will be 3. So we can take any coordinate, we will get the same slope. So whenever in the question it is given as rate of change in something, or you have to find something per unit. Let me explain. Let's say on x-axis you have hours, and on y-axis you have kilometers. So if in the question it is asked what is the rate of change in speed, or what is the speed, or what is kilometer per hour, so whenever rate or per is given in the question, then you have to find slope. Now this was an example of a positive linear equation where slope m was positive. Now let's take another example of a negative linear equation. A linear equation is called a negative when slope is negative. As we can see here, m value is negative 3. Now let's solve this example here. Y is equal to minus 3x plus 2. Now let's put this linear equation on the graph. So when x is equal to minus 1, so minus, let's put x value as minus 1. So minus 3 into minus 3, that would be plus 3, plus 2, that would be 3 plus 2, that would be 5. So when x value is minus 1, y is 5. Similarly, when x value is 0, so let's put 0 here. So minus 3, x value is 0. So then y is equal to 2. So this is your y-intercept. Similarly, when x is 1, y is equal to minus 1. When x is 2, y is equal to 4. Now let's put these coordinates on the graph. As we can see, we are moving from minus 1 to 2. So when x is equal to minus 1, y is equal to 5. So y is equal to 5. So this is it's coming is equal to 5. Then this is 0, 2. Here x is equal to 0 and y is equal to 2. And this can be also called as a y-intercept, because here x value is 0 and y is 2. Now when x is 1, y is negative 1. So x is positive 1 and y is negative 1. 1. Then when x is 2, so x is 2, y is negative, y is 4. I think it should be negative 4, I guess. Let me check one more time. Minus 3 into 2 plus 2. So it's going to be minus 6 plus 4 plus 2. That would be negative 4. So this is going to be negative 4. 2, negative 4. Now, now we have plotted this linear equation, and as we can see here, the whenever we are increasing the value of x, y value is decreasing from positive 5 to negative 5. So it is this graph has a negative slope as the line of the graph is moving in downward direction. Now let's find the inverse of this. Let's say this graph was given to us with some coordinates, and we have to find the linear equation. So as we know, y is equal to mx plus b. So b is our y coordinate. As we can see here, when x is equal to 0 on this coordinate here, then y is 2. So b y-intercept would be 2. Now what is going to be our slope m here? So slope m is equal to as we have read in the positive linear equation, rise by run. But here the graph is decreasing, so instead of rise, we will have fall, that is falling, and by run. So that is delta y divided by delta x. That is equal to y2 minus y1 divided by x2 minus x1. Let's take any two coordinates here. Let's take these two coordinates here, this one and this one. As we can see, we have plotted this data first, so we'll take this one as x1. So x1, and this is your y1. Similarly, we have plotted this data after this data, so this is going to be our x2 and y2. So our slope is y2 minus y1, so y2 is 2, so 2, and y1 is 5, so minus 5. So 2 minus 5 divided by x2 minus x1, so x2 is 0, 0, and minus negative 1. So that would be negative 3, and negative negative, so 0 plus 1, so that is going to be minus 3. So your slope is negative here. So this is our basic equation. So what we're going to do is we're going to put the value of m and b here. So y is equal to m, that is slope, that is negative 3. So minus 3x plus b is our y-intercept. So b was 2. So this is our linear equation for this graph. Now to sum all the things up, to sum up, so this is our linear positive equation, positive linear equation, and this is our negative linear equation. In positive linear equation, as we can see, slope m value is positive, and we will have a graph that is rising in nature like this. Now, there's one more thing that you need to remember about positive linear equation. In positive linear equation, both x and y value increase or decrease at a regular interval. Let me tell you what I'm trying to say here. As we can see here, when x value is increasing from -1 to 0, so it is increasing by 1 unit. The y value is increasing from -1 to 2, that is 3 unit. Now again, when x value is increasing by 1 unit, y value is increasing from 2 to 5, that is 3 unit. When x value is increasing by 1 unit, y value is increasing by 3 unit. So always remember, in a positive linear equation, both x and y value increase at a regular interval. So here x is increasing at an interval of 1 unit, and y is increasing at a interval of 3 units. Now in a negative linear equation, slope m is negative. So here our slope m value is -3, so it is a negative linear equation, and the graph for it will be falling like this. And always remember, when x value is increasing at fixed interval, then y value is decreasing at fixed interval. So as we can see here, x value is increasing from -1 to 0, so it is increasing by 1 unit. Then y value is reducing, it is decreasing from 5 to 3, so it is reduced by 3 units. So now when x value is increasing from 0 to 1, that is 1 unit, y value is decreasing from 2 to -1, so it is reducing by 3 units. Similarly, when x value is increased from 1 to 2, that is increase of 1 unit, y value is reduced from -1 to -4, that is a reduction of 3 units. So always remember, for a negative linear equation, x value would increase, then the y value would decrease, or vice versa of that. Now let's move on to the questions now. In question number 1, it says that each dot in the scatter plot above represent the height x in feet in high jump. So this is our x-axis. On x-axis we have high jump in feet, and distance y in feet in long jump. So on y-axis we have long jump distance made by each students in a group of 20 students. So we have 20 students, and their respective high jump in feet on x-axis is given, and on y-axis their long jump distance is given for those 20 students. So these 20 data points are of 20 students. We have to find that the graph of which of the following equation is a line that most closely fits the data. So what we're going to do here is, first we have a scatter plot here. To find the equation, we need to find what is the slope. So for slope, first we have to find what is the line of best fit, LOBF, line of best fit. We have read about the line of best fit. It should follow two conditions. First condition, it should approximate slope. The line of best fit should approximate slope or trend of data points. So as we can see, all our data points are moving in upward direction. So it's a positive slope. So our line of best fit would be like this. It will have a positive slope. Now, second thing is the the line of best fit should split the data in half, data points in half, data points in half. So we have 20 data points because 20 students are there. So we have 20 data points. So we have to draw a line that should approx the slope trend. So we are moving in upward direction. So all our line of best fit would be in upward direction with a positive slope, and it should split the data points in half. So wherever we are drawing the line of best fit, we should have 10 data points above the line and 10 data points below the line. So this is our line of best fit. So as you can see here, this is a line of best fit. It is satisfying the first condition because it is approximate the slope or the trend. So it is moving upward direction, and it should split the data in half. So this is our line of best fit. So on above line of best fit, let's count how many data points we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 we have below. So line of best fit have split the data points in half. So this is our line of best fit. Now, as we know the equation, y is equal to mx plus c. So c is your y-intercept. What is y-intercept? So value of y at x equal to 0. So if we follow this line of best fit, we can see here the y-intercept is somewhere near 1. So y-intercept is approximately around 1. So here, if we see, so this is our basic equation. So if we check the y-intercept here, so we have 3.3 and 0.82. So as we can see that the y-intercept here is somewhere near 1. So we will cancel these two options, 3 and 3, and only will consider option B or C because the y-intercept is around 1 here. Now let's find the slope here. So m slope is equal to y2 minus y1 by x2 minus x1. So let's take 2 points on the slope here. Let's say 5 and 16. This point, let's take this point, 5 and 16. And this is our, and let's take one more point here, that is this one, starting 0 and 1. So as we can see, this is our x1, this is our y1, this is our x2, this is our y2. See, we have to select 2 points on the slope where we can get a whole number, corresponding whole number. So if we take this point here, we are getting a whole number on y-axis, and we are also getting a whole number on x-axis. Similarly here, we are getting 1, y is equal to 1 and x is equal to 0. So we are getting whole numbers here. So slope is change y2 minus y1 divided by x2 minus x1. So y2 is 16, y1 is 1, x2 is 5, so 5, and x1 is 0. So it is going to be 15 divided by 5, so 3. So slope is 3. So now what we're going to do here is, this is our basic equation. And what we're going to do here is, we are going to put the value of slope and y-intercept. So y is equal to 3. So as we can see here, because we have to find the most closely fit the data. So 3, our slope m is 3. So it is approximately near 3.3. So we will take 3.3x plus c is your y-intercept. So y-intercept is somewhere around 1. So that is plus 0.82. 0.82. So option B is your correct answer. Now let's move on to the next question. In question number 2, in part 1 of the question, which of the following best describes the correlation seen in the graph? So as we can see, this is our line of best fit. So as we can see, it is line of best fit is moving in upward direction. So our slope is positive. So our slope is positive. And as we can see, the data points are concentrated near the line of best fit. So as we can see, most of the data points are near the line of best fit. So the concentration of data points is high near the line of best fit. So what kind of relation? So slope is positive. So we have positive, 2 options here as positive. But here, as we can see, the concentration is high because most of the data points are near the line of best fit. So the concentration is high. So we will call this relation as high positive correlation. Now, if we had data points here, like here, 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 and here, 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 here. So now what kind of correlation we are going to have? So slope is positive, so still it is going to be positive, but now the data points, the concentration of data points are low because data points are far, far away from the lines of best fit. So the concentration is low because a lot of data points are very far away from the line of best fit. So for this example, we will have low positive correlation. Now, in second part of this question, what is the approx equation of line of best fit? So as we know, y is equal to mx plus b or c, whatever you can. So as we know, b is our y-intercept. So y-intercept is value of y at x is equal to 0. As we can see, it is somewhere, y-intercept is here, that is 0, 200. So at x is equal to 0, y is 200. So our y-intercept is 200. Now we have to find the slope. So slope m is equal to delta y by delta x. That is y2 minus y1 divided by x2 minus x1. So let's take 2 coordinates here. So first I'm taking a coordinate here where x is 0 and y is 200. Now let's take one more coordinate here. Let's say this one. At here we have x value is 30, so 30, and here y value is 450. So this is going to be our x1, and this is going to be our y1, and this is going to be our x2, this is going to be our y2. So we have to find the slope now. So y2 minus y1, so 450 minus 200. So 450 minus 200 is 250, and x2 minus x1, that is 30 minus 0. So 30 minus 0 would be 30. So what is going to be our slope? So it is approximately around 8 here. So this was our basic equation. So from this, we can say that y-intercept is 200. So we will take either option B or option D. We'll discard these 2 options. Now our slope m is 8. So from this we can say that y is equal to slope m, that is 8. So 8x plus y-intercept b, that is y-intercept, that is 200. So option D is your correct answer, and for this option A was your correct answer. Now in third part of the question, how many additional calories would be predicted if fat intake increases from 50 to 80 gram? So as we can see here on x-axis, we have fat in grams, and on y-axis, we have calorie. And we already know the equation for this line of best fit, that is y is equal to 8x plus 200. We have solved it in the previous part of this question. So we have to find the additional calories if fat intake increases from 50 to 80. So fat is x here on x-axis. So what we're going to do here is we are going to put uh, uh, because x is your fat and y is equal to your calorie. So we have to find the calorie when fat is 50 and 80%. So y is your calorie. So instead of x fat, we will put 50 plus 200. So 8, 5, 40. So 400 plus 200, that would be 600. And as we can see here on the graph also, 50 grams of fat, we have 600 calories. Now 80 grams of fat, for 80 grams of fat, how many calories would be there? So 8, and instead of x, we will put 80 here. So 8 into 80 plus 200. So 8 into 640, 640 plus 200, that is 840. So we have to find the additional calories. So additional calories would be difference of these two. So 840 minus 600. So that is going to be 240 calories. So this is 240 calorie is your answer. Now in part 4 of this question, for a 25 grams of fat, 25 grams of fat, which of the following is the percentage decrease from the actual calories to the calorie predicted by the line of best fit? So for 25 gram of fat, we have line of best fit here, and we have two data points given here. So which one we are going to consider? Because in the question we have to find the percentage decrease from the actual calories to the calories predicted by line of best fit. So we will, because there's a decreasing, so we will consider this data point. We're not going to consider this data point because in the question we have to find the percentage decrease. So from here to here it is decreasing. So what we're going to do here is we have to find the calories for this data point and here. So we have to find what is the calorie at these 2 points. So what we're going to do here is, so for 25 grams of fat, the actual calorie, so actual calorie, so here we have 25 grams, so actual calorie is 500 grams. So actual calorie is 500 gram, and calorie on line of best fit. So for 25 gram, if we go from here on line of best fit, we have 400 calories. So 400 calories. Now we have to find percentage decrease. So as we can see in the question, it is given which of the following percentage decrease from the actual calorie. So our actual calorie is 500. So percentage decrease 500 minus calories on the line of best fit divided by, because we, after from is given for the actual calories, so we will have 500 in the base, that is the actual calorie, and we have to find the percentage, so into 100%. So this is going to be 100 by 500 into 100%. So if you can, and 2 times, so 20%. So the percentage decrease from this actual point to the point on the line of best fit is 20%. So option C is your correct answer. And question number 5, which of the following is the average rate of calorie per 1 fat gram? So whenever we have to find average rate or calorie or anything per gram or any per unit, so that means we have to find the slope. So now how are we going to find the slope here? So as we know, m is equal to y2 minus y1 divided by x2 minus x1. So we have already found the slope in part 2, that is that was approximately around 8, so it would be 8 calories. So whenever in the question we have to find the average rate or anything per unit of something like kilometer per hour, distance traveled in kilometer per hour. So whenever we have given per or average rate, we have to find slope. So slope is already, we have already found the slope in part 2 of the question, that is 8. So 8 calories will be your answer. Question number 3, it says that the scatter plot shows the relationship between two variable x and y. So we have x variable here and we have y variable here. A line of best fit is shown. So this is our line of best fit, and it is having a negative slope. So which of the following equation best represent the line of best fit? So normally when we have a negative linear equation, our value of slope m would be negative plus our y-intercept. So as we can see here in the option, the value attached to x should be negative. So it can be either option C and option D. In option A and B, the value attached to x, that is slope, is positive. So we will discard these two options. Now, B is our y-intercept. B is our y-intercept. So y-intercept is the value of y when x is equal to 0. So at this point, as we can see, x is 0 here and y's value is between 13 and 14. So 13.5. So x is 0 and y is 13.5. So what is going to be our y-intercept? 13.5, because at x is equal to 0, y's value is 13.5. Now we have to find the slope. So for slope, let's consider two coordinates here on the slope. So this is our first coordinate, 0 to 0 and 1, 13.5. Let's take another coordinate. Let's take this coordinate here. So x is 13 and y is 3. So this is our x1 and y1. This is our x2 and y2. To find the slope m, that is equal to delta y by delta x, that is y2 minus y1 divided by x2 minus x1. So y2 value is 3. So 3 minus y1, that is 13.5. So 13.5 divided by x2 is 13. x2 is 13 and x1 is 0. So that is going to be 9.5 divided by 13. Let me put it on my calculator. So it is going to be approximately around 0.8. So now what we're going to do here, this is our equation, y is equal to mx plus b. Sorry, one more thing, that is 3 minus 13.5 is negative 9.5. So this is also going to be negative. So y is equal to mx plus b. So our slope m is negative 0.8x plus b. B is our y-intercept, that is 13.5. So this is your answer. So option C is your correct answer. Let's move on to the next question. In question number 4, when there are X milligrams of a certain drug in a patient's bloodstream, a patient's heart rate H in beats per minute can be modeled by the equation H is equal to 70 plus 0.5x. Which statements are true? So this is our basic linear equation, 70 plus 0.5x. So here H is your heart rate, and X is your drugs in milligram, and heart rate is in beats per minute. So we have to find which of the following statement is true. So in first statement, 10 minutes after taking the drug, the patient's heart rate increases to 75 beats per minute. So here 10-minute time is given, but in the equation, in this one, we are only given two things, that is heart rate and drugs. Time is not mentioned anywhere in this equation. So statement 1 would be wrong, because time is not mentioned anywhere in this equation and the time does not have any effect on heart rate or drug. So statement 1 is incorrect. Now let's come to the statement 2. When the drug is not in the bloodstream, so drug is X here, So drug, so if we put if there's no drugs, means x is 0. If drug is not in the bloodstream, the patient heart rate is 70 beats per minute. So what we're going to do here is we'll take this equation 0.5x, and in statement 2 it is saying that drug is not in the bloodstream. So drug is x, so there is no drug at all, so x would be 0. So 70 plus 0.5, and there is no drug at all, so this is going to be 70. So hence heart rate h is equal to 70. So the patient heart rate is 70 beats per minute. 70 beats per minute. So statement 2 is correct. Now, for each 10 milligram increase of drug in patient's bloodstream, the patient's heartbeat increases by 5 beats per minute. So what we're going to do here is first we will take the drug value 0 gram, and let's increase it by 10 milligram. So 10 milligram. It's not in gram, it's milligram. So, and now let's increase it to 10 milligram. So we already have found what is the heart rate when drug is 0 milligram. So that is 75. Now let's find the heart rate when the drug is 10 milligram. So heart rate h is equal to 70 plus 0.5x. So instead of x, that is drugs, that is we will put 10 milligram. So that is 70 plus 0.5 to 10. So that is going to be 70 plus 0.5 into 10, that would be 5. So 75 beats per minute. So at 0 it was 70 beats per minute when there was no drugs at all, and 10, and when we increase the drug dose by 10 milligram, it is 75. So the statement 3 says that for each 10 milligram increase of drug in the patient's bloodstream, the heartbeat increases 5 beats per minute. So heartbeat, so at 10 milligram it is 75, and at 0 milligram it is 70. So heart rate increases 5 beats per minute. So for statement 3 is also correct. So option D is your correct answer. In question number 5, the question says that a fitness class was started at several fitness clubs owned by the same company. The Scatterplot shows the total number of people attending the class during first 5 months in which classes were offered. The line of best fit is drawn. So in part 1 of the question, we have to find for month 4 the predicted number of people. So predicted number of people attending the classes was approximately what percent greater than the actual number of people attending the classes. So this is our month 4 here. This is our month 4. So we have to find first the predicted number. So predicted number is on the line of best fit. It is slightly below 800 people. So this is our predicted number of people attending the classes. So this is it. And the actual number is this one. So this is 4 and 600. And this one is 4, slightly below 800. So 4, 780. So we have to find, for month 4, we have to find the predicted number of people attending the classes approximately what percentage greater than the actual number. So actual number is 600 and the predicted number is 780. So we have to find the percentage greater. So what we're going to do here, we're going to subtract these two, 780 people minus 600 people. And after then, in the question, actual number is given. So actual number of people is 600. So we will take 600 in base. And this is given in fraction. If we have to, because we have to find the percentage, so we will multiply the fraction into 100% to convert fraction into percentage. So this is going to be 180 divided by 600 into 100%. So this got cancelled, this and this got cancelled. So 6 3 times, 3 into 10, that is 30%. So option D is your correct answer. See, two numbers are given here. So we have to find which among these two numbers we are going to take in the base. So whatever the thing that is given after then, we will take that number as a base. So after then, the actual number of people, that is 600 is there. So we will take 600 as base. And if we have to find grade. After then it was given, the predicted number was given, then we will take 780 as the base. Now in part 2 of this question, during the first 5-month period, the average increase in the number of people attending the class per month is closest to which of the following? So as we have already seen in question number 2, whenever average rate is given or anything per unit is given in the question, that means we have to find the slope. So now what we're going to do, we'll take any 2 point on the slope. Let's take this point, that is 0 and 300, and let's take one more point here, this one, that is 5 and 900. 5 and 900. So what is slope? Slope is delta y divided by delta x. So we, instead of writing the whole thing, so this is our delta y. So it is starting from 300 and it is going up to 900. So 900 minus 300, that is 600. So our delta y is 600. And what is our delta x? So it is starting from month 0 and it is going up to 5th month. So 5 minus 0. So delta x is 5 minus 0, so 0. So our slope m is delta y by delta x. So delta y is 600 and delta x is 5. Sorry, 5 minus 0. 5 minus 0, that is 5. So 5. So our average rate increase would be 600. This will go 600, 120. So option C is your correct answer. Now, in third part of this question, at the beginning of which month did the actual number of people attending the class differ by the greatest amount from the number predicted by the line of best fit? So this is, we every month we are getting two datas. One, that is the predicted data on the line of best fit, and these data points shows the actual number. So in first month we have here the line of best fit, that is the predicted number, and this is our actual number. In month 2, let's see, we have this one as a predicted number on line of best fit, and this is our actual number of people. It will tell us the actual number of people. In month 3, we have here and here. In month 4, we have here and here. And in month 5, both are at the same point. So in the question, we have to find at the beginning of which of the month did the actual number of the people. So actual number of the people attending the class differ by the greatest amount from the number predicted. So for every month, we have to see which is having the highest difference. So here we have very small difference. Here we also have in month 5, we have very small difference. Here we also have in month 3, we have very small difference. Now let's see in month 2 and month 4. In month 2, we have a difference of almost 300 people, because it is 800 and this one is somewhere around 350. So it is more than, and here we have a difference of 200. So the greatest difference is in month 2. So your answer would be month 2. In part 4, how many months of these 5 months have people attending the classes that differ more than 150? So we have to find the month where the difference between the predicted number and the actual number is greater than 150. So here we can see the difference is not greater than 150. In month 2, we have difference greater than 150 people. Now let's see this one. So this one is not more than 150. It will be somewhere between 100 and 150. So this one, month 3 will not be there. Now in month 4, the difference is of 200, 800 and 600. So it is more than 150 people. So we will take month 4. And here both the points, that is predicted and the actual number of people, are at the same place. So here the difference is 0. So for 2 months, that is month 2 and month 4. In question number 6, the question says that the bar graph below shows the verbal and math SAT score for 5 students labeled A to E. If scatterplot of the data in the bar graph is made such that the math SAT score for each student is plotted along x-axis and verbal SAT score is plotted along the y-axis. So we have to find how many of the data points would lie above the line when y is equal to x. So the question says that the math SAT score is on x-axis. So math SAT score, we have that on x-axis, and verbal SAT score on y-axis. And how many of the data points would lie above the line y is equal to x? So we have a line equation that is y equal to x. So x and y. And as we can see here, their score is moving from 0 to 800. So what we're going to do here is on the graph, we'll take this as 0, this one as 500, and this one as 1000, 500 and 1000. So now we have to draw the line, and the equation of line is y is equal to x. So if we take value of x is equal to 0, y would be also 0. If we take x is equal to 500, then the line y would be also 500. And if we take x as 1000, y would be 1000. So this is going to be the line. So 0, 0. Then this 500 and 500, where x and y value is 500. And then if x value is 1000, then y value is also 1000. So this is the straight line where y is equal to x. Now what we're going to do here is we are going to put all the student A, B, C, D, E, their math SAT score and verbal SAT score here. So let's say here, as we can see in the graph, for student A, math SAT score is 500. So x is, because math SAT score is on x-axis, so x is 500, and verbal, that is on the y-axis, so it is 600. So now we're going to put point A here. So x is 500, so 500, and y is 600. So y is 600. So we get this point A. Now point B is 650 and 550. Point C is 700 and 650. D, for student D, is 650 and 600. And for student E is 750 and 700. So now we can see that only one point, that is A, that is above the line, and rest B, C, D, and E, these four students are below the line, that is y is equal to x line. So we will have, so in the question it was given how many of the data points would lie above the line y is equal to x. So that we have only one line that is above line y is equal to x. So option D is your correct answer. Now this was your normal method. There's one shortcut method also for this question. Shortcut method. We have read this in linear equation. Whenever the line y is equal to x, so all the data points above this line would be where y would be greater than x, and the data points below this line would be where x will be greater than y. So now we have to see the option where y is greater than x. So as we can see here, for student A, the value of y, that is verbal score, is greater than the value of x, that is math SAT score. So we have only one remaining here. X is greater. This one also, x is greater than y. X is greater than y. X is greater than y. This one is for student A, the math SAT score was less than the verbal SAT score. And for this one, for student D, x is greater than y, and for student E, x is also greater than y. So we have only one student for whose x value is less than y. So it will, so this, so the data point of student A would lie above the line. Now moving to the next question. Question number 7. It says that scatterplot below shows the high temperature on a certain day and the elevation of 8 different locations in the Lake Tahoe Basin. A line of best fit for the data is shown. Which of the following statement best describes the association between elevation and temperature? So on x-axis we have elevation, and on y-axis we have temperature. So let's look at the first option. As elevation decreases, So elevation, high elevation is on that side. So if we move from this side to this side, if when elevation decreases, temperature decreases. That is not the case, because when we are moving from 9,000, when we are here near 9,000 feet, the temperature was 37.5, and when we decreased it, the temperature was around 44. So here, when elevation decreases, here temperature is increasing. Now let's look at option number 2. When elevation increases, so now elevation is increasing, the temperature tends to increase. So when we are moving from this side to this side, so elevation is increasing. We are seeing that temperature here, elevation was 6,000, the temperature was 44. Here, elevation is near 9,000, the temperature has reduced. So when elevation increases, temperature decreases. So option B is also incorrect. There is no association. No, there's an association. Now look at the option D. When elevation increases, so elevation increases, temperature tends to decreases. So as we can see here, at 6,000 elevation, we're having a temperature around 44 degree Fahrenheit. And when we move toward higher elevation, that is 9,000, the temperature is 38. So the temperature is decreasing. So option D is your correct answer. Question number 8, it says that the table shows selected values for function fx, function f. Which of the following is the best description of the function? So we have to say that this function, this a table is given, and we have to tell that the function is decreasingly linear, increasingly exponential, decreasingly exponential, or increasingly linear. So what we're going to do here is we're going to see the value of x and y. So as we can see, value of x is increasing from -1 to 0. So we have 1 unit increase here. And whenever we are increasing the value of x by 1, the, the function or the y value increase from 6 to 8, that is +2. Similarly, again, when we increase the value from 0 to 1, that is increase of 1 unit in x, then the value of y or fx increases by 2. Similarly, when the value of x is increased from 1 to 2, then the y or fx value is increased by 2. So whenever, so always remember, for linear function, for linear function, for linear function, when value of x increase or decrease by fixed interval, then value of y increase or decrease by fixed interval. So as we can see here, when x value is increasing by 1 unit, y or fx value is increasing by 2 units. So we can say that this table is having a linear function. Now we have linear here and linear here. So we have to tell that this is a decreasing linear function or an increasing linear function. So as you can see here, the x value is increasing, then y value is also increasing from 6 to 12, when x value is increasing from -1 to 12. So it is an increasing linear function. So option D is your correct answer. Now we can also check that this is a increasing linear function or not by putting the value of x and y on the graph. So this is a x, this is a 0 here. So for minus, when the value of x is -1, then the value of y is 6. So -1, the value, then y is 6. So y is 6 here. When x is equal to 0, y is 8. Similarly, when x is equal to 1, y is 10. And when x is equal to 2, y is 12. So when x is 2, y is 12. So as we can see, this one is this line is forming a linear increasing function because it is moving upward direction. So it is an increasing linear relationship. Now let's move on to the next question. So in the question, it is asked that in which of the following table non-linear relationship between the value of x and the corresponding value of y. So as we know, as we have read in the linear function, that when the value of x increases or decreases by fixed interval, the value of y also increases or decreases by fixed interval. And those who does not follow this thing are called non-linear function. So as we can see here in the first table, when there is an increase of 1 unit in x, y increases by 3 units. Here also, when there is increase of 1 unit, the y increases by 3 units. 1 unit increase, y increases by 3 units. So we can call it as a linear, positive linear relationship. Now let's come to the second table. When x is increasing by 1 units, y is decreasing by 4 units. So this is a, now let's take another value. When it is increasing by 1 unit, x is increasing by 1 unit, y is decreasing by 4 units. When again, when x is increasing by 1 unit, y is decreasing by 4 units. So this is a linear, this is also a linear, this is also a linear function, because the interval between x and y for the values of x and y is same. But the only difference here is when x was increasing by 1, the y value was also increasing, so it was a positive linear. But here, when x value is increasing by 1 units, y value is decreasing by 4 units. So this is a negative linear relationship. Now let's see the table number 3. 1 1 1 increase, plus 1 plus 1 plus 1. Here we are increasing by plus 5 plus 5 plus 5. So this is also a linear, and when x value is increasing, y value is also increasing, so it is a positive linear relationship. Now let's come to table number 4. Here we are increasing x by 1 unit, so plus 1 plus 1 plus 1. Here, when we are increasing x by 1 unit, y is increasing by 6 unit. When we increase x by 1 unit, y is increasing by 12 units. And again, when we are increasing x by 1 unit, y is increasing by 24 units. So this is a non-linear relationship. So non-linear relationship, or if when we put this on the graph, it will look like an exponential graph. Exponential graph. So in the question it was asked, which of the following table is the non-linear relationship? So table number 4 is having a non-linear relationship. So option B is the correct answer. To sum up linear and non-linear relationship, in linear relationship, x and y value increase or decreased by fixed interval. Uh, as we can see here in first 3 tables, x value and y value are increasing at fixed interval. And non-linear relationship are where x and y value are increasing or decreasing by variable intervals. So as we can see here, first it is increasing by 6 units, then 12 units, then 24 units. So it is a variable interval. So whenever x and y value is increasing or decreasing by variable interval, then it is a non-linear relationship. When x and y value is increasing or decreasing by fixed interval, then it is linear relationship. Now in linear, we have positive and negative relationship. So when x value is increasing at fixed interval, y value is also increasing at fixed interval, then it is called as a positive linear interval. But when x value is increasing at fixed interval, but y value is decreasing at a fixed interval, then it is called as a negative linear relationship. Now let's move on to the next question. Question number 10, it says that the scatter plot below shows the data of 10 charities along with the line of best fit. For the charity with greatest percent of total expenses spent on programs, which of the following is closest to the difference of the actual percentage, that is data point, and the percentage predicted by line of best fits? So in the question, for the charity with the greatest percent of total expenses, so we will see which of the data point is having the highest or the greatest percentage of total expenses. So as we can see here, this one is having somewhere around 92%. So 92%. So this is the charity with the greatest percentage of total expenses. So so our actual percent is 92%, and the percentage predicted on line of best fit. So if we go down here, it is coming somewhere near 85. So the percentage predicted on line of best fit is 85%, and the actual percent is 92%. So we have to find which of the following is closest to the difference of actual percentage. The actual percentage is 92%, and the percentage predicted by line of best fit is 85. So we have to find its difference. So the difference would be 92% minus 85%. So that is 7%. So option C is your correct answer. In second part of this question, for how many of 10 data points is the actual y value is greater than the y value predicted by the line of best fit? So this is our line of best fit. So all the values, any data point located above line of best fit where actual value is greater than the y value predicted by line of best fit. So we have to check how many data points are above this line of best fit. So we have 1, 2, 3, 4, 5. So we have 5 data points, because if we take this point here on the line of best, it is 85%, and the actual y value was 92%. So all the data points above the line of best fit will have actual y value greater than the y value predicted by the line of best fit. So we have 5 data points. So option B is your correct answer. Now, this is your last question. The scatter plot above shows a company ice cream sales D in dollars and the high temperature T in degrees Celsius on 12 different days. A line of best fit for the data is shown. Which of the following could be the equation of line of best fit? So as we can see, we have a positive slope here. So what is the basic function? Y is equal to mx plus b. So as we can see here, on y side we have d, on y we have $d. So we will y is equal to d. On x side here, on the x-axis we have temperature T. So x is your temperature. So we can replace y and x with dollars and temperature. So m T plus b. Now, as we know, m is your slope. M is your slope. So slope is delta y by delta x. So let's take 2 points on uh, on the slope. So we'll consider this point here, and let's take one more point. So this point is 12,480, and let's take one more point here. That is, take this one, 24, and it's slightly less than 900, so 880. So now we have two coordinates on the slope. Now we can find the slope. So delta y is y2 minus y1. So y2 is 880 and y1 is 480. So 880 minus 480 divided by x2 minus x1. So x2 is 24 and x1 is 12. So 24 minus 12. So this is going to be 400 divided by 12. So it will be 33 point something. So our slope m is 33. So now we can write this equation. We can put slope in this equation. So d is equal to m, slope is 33 t plus b. Now if we have to find b is our y coordinate. So if we have to find the value of b, so we can write it as d minus 33 t. So we have taken two coordinates on the slope. So let's take this coordinate here, this one. So coordinate 12 and 480. So this is your x value, this is your y value, but here x value is temperature, so this is your T, and y value is sales in dollars, that is D. So we are going to put these coordinates in this equation. So B is equal to D D is 480. D is 480. 480 minus 33, and T is 12. 12. So if we subtract it, let me put it on my calculator. So if we subtract it, so your y-intercept is 84. Now we can put the slope value and the y-intercept value in this equation. So D is equal to slope M is 33. So 33 T, and y-intercept is 84. So option C is your correct answer. Now, these are 5 practice questions on the topic which I've taught you recently in this video. Do solve these questions to test yourself and write down the answer in the comment section. Don't forget to watch part 2 of Scatterplot. In part 2, I'm going to take Scatterplot problem related to parabolic and exponential function. If you like the way I teach and want to buy a comprehensive course for SAT exam starting at a very affordable price, you can check out our homeschooling app and website. All the links are provided in the description below. One more thing, don't forget to like, share, and subscribe to this channel so that you can get updates of upcoming free videos that I'm going to upload on YouTube in future. Thank you very much, and may God bless you.